Hello, hello, hello everybody, and welcome back to more of our 2010 Galois paper. We're on question number 2. Of course, question number 1 was in the last video, so if you're looking for that, feel free to go back and watch that video. We're on question 2 here, which has 4 parts, and you'll never get 5 parts on a Friar Galois or Hypatia. They always seem to be restricted to at most 4. So part A for question number 2, quadrilateral QABO is constructed as shown. Determine the area of our quadrilateral. Now, it's not just a quadrilateral. So I can see here that Q and A have the same y coordinate. So this line here is just a horizontal line. It's going to be flat. It's going to be parallel to our x-axis here. So this thing here is actually a trapezoid as well. Now we have 2 ways we can go about doing this question. One, you could create another point down here. Let's call him C, I guess. And you could get a rectangle here of height 12 and width 2, and then get a right angle triangle here and do 1/2 base times height. That's a perfectly fine way to do the question. I'm going to point out that it's a trapezoid in my solution and use the formula for the area of a trapezoid. Either way is fine. You'll get the same answer. But, so Q, A, O, B. So we get, well, first of all, let's make this x-axis a little more convincing. Okay, so I would say something like, notice that AQ is parallel to BO. So QABO is a trapezoid. So a trapezoid, if I know the height of the trapezoid, which I do in this case, and I know the length of the 2 parallel sides, the area is 1/2 H A plus B. Okay, so you don't really need to justify this as long as your numbers are correct, but AQ is 2. BO, I think it was 12, was it? Yeah, so this distance from the origin over just the difference in the x coordinates is 12, and the height is QO, which is also 12. Difference in the y coordinates this time. So the area of QABO is 1/2 height times the sum of the parallel sides. So 1/2, 12 times 14. So that'll be 12 times 7, and that'll be 84. Okay. So there we go. Nothing else to do there. We've got the height of our trapezoid. So what's going on for B part? Point C, so I guess my point C up here doesn't really count. C, OP, so it lies on the y-axis. Between Q and O is shown here. Determine an expression for the area of COB, so COB here. And we don't really have any other pictures, so do we use C in later parts? Yeah, so C part, I'm just reading ahead now. Determine an expression for the area of QCA, so we want this, and we want this. Both of them are going to be in terms of P. D part. If the area of ABC is 27, determine the value of P. So this one, probably would be nice if I had ABC in terms of P, and then was able to set that area equal to 27, and then solve for P. I think that'd be fine. So I can actually do all 3 of these together almost. We'll redraw the picture here. So I'm splitting my trapezoid up. Now, in A part, we figured out the area of this trapezoid. We have 12 here. C is 0P. So that means, we'll put those there. This is a 2 here. And we get some right angles. Things should be clearly labeled on your picture. Now, the height here is P, and the height here is 12 minus P. So we can do all these together. If you're going to, maybe mention that B is what you're doing now. So B is area of COB is 1/2 base times height. So that's just 6p. C part, the area of ACQ is 1/2 base times height. So that'll just be 12 minus p. And as for D part, the area of ABC is the area of QABO minus these two smaller triangles that we just figured out. So this is 84 minus 6p minus 12 minus p. So that'll be 84 minus 6p minus 12 plus p. 84 minus 12 is 72. 6p, subtract another p, so that'll be minus 5p. Okay. So if 27 is ABC, that's 72 minus 5p. I'll bring the 5p over to the other side. 72 minus 27 is 45. So p is going to be 9. There we go. That actually went really, really fast. You might be wondering, well, what sort of explanation should I give for B and C? Clearly state that you're using 1/2 base times height, and that the height here is p, and that the height here is 12 minus p. You could even take the difference of the coordinates for CQ if you really wanted to. And for ABC, I would say as long as you clearly state where you're getting your formula from, that it's the trapezoid minus the two other triangles that you get from parts B and C, you're fine there. And then 27 is equal to 72 minus 5p. Nothing else to do there, and so p is going to be 9. I don't think we were asked for anything else. Nope, determine the value of p, determine expressions in terms of p. We're all set. So, yeah, sometimes reading the whole question, you can do multiple parts together. This usually is more common for like a question 4 if they introduce a brand new concept or something like that. But, it can happen any time, and all I did was realize, well, they only have one more diagram, so it's probably going to apply to a couple of these. And it did. Yeah, that question 2 went by a lot faster than question number 1. Hopefully question 3 will continue the trend, and maybe question 4 will only take me a minute. Dare to dream. I will see you guys in the next video for question number 3 as we continue on with our 2010 Galois paper.